the assignment is up for 5.1. Before you do that though, before you do anything, before you go back and do anything from chapter 4, and you can. But the first thing you have to do when you get down there, I put up a little very, very short e-ticket, just it's called 5.1 e-tick. It's got 4 problems. I want you to do that immediately when we get there so I can just see where everybody is on this stuff. It's not difficult. It's stuff like this. It's been a weekend, so let's just take a second and just review what we talked about on, I think it was on Friday. So what can we do with this? So we're told, look at this problem here. We're told that, what is that thing? Be careful now. What's that mean if we write CD with that symbol over the top? Okay, so line CD is the perpendicular bisector of segment AB. Okay, then we're supposed to write an equation representing the relationship between, what's that? AC. What does that mean? It is we'd probably just say AC, but what does that stand for? When there's no symbol over the top, what is that? Say it again. Side. Okay, what about a side though? It doesn't have a symbol over the top, so it means something specific. It's a what? Say it again. The length of the segment, right? Or the distance between the points, same thing, right? So that's because there's no symbol, that's a number, right? It represents an actual number. That means the length of the segment. So we want to see if we can come up with a relationship between the length of segment AC and the length of segment BC. So before we do anything with this, let's just take the given information, right? Can we mark up our drawing? And I really want and expect you to start doing more of this. So all this stuff needs to be in your notebooks when you're doing these problems. Write down, just quickly crank out a picture in your notes that you can write stuff on. So what can we do with this? Are there any marks we can add to this drawing to relay all that information in the blue? What's one thing we could add to our picture? A right angle, sure. Because we're told that line CD is the perpendicular bisector of segment AB, right? So we could put a right angle sign there to show that they're perpendicular, right? Okay, what else? Yes? Perfect. Perfect, yeah, because it's a bisector, right? We know that this line bisects segment AB, so it must cut it into 2 equal or congruent pieces, right? So those few little blue marks there summarizes all that stuff. Now, what can we add based on what we learned on Friday, right? We added something called the perpendicular bisector theorem on Friday, and that told us something important. It said, I'll get you started, it said if a point, in this case point C, lies on the perpendicular bisector of a segment, in this case segment AB, then what? Something important came out of that. What was the result? What do we know about point C? Remember we did the thing on the board with the geometer sketch pad? We explored distances and we found something interesting. What distances did we find were always related if point C is a point that could, somewhere we could slide along this? What do we get? Okay, good. So in the wording of the actual theorem, we would just say that point C, if it's on the perpendicular bisector, is equidistant from the endpoints of the segment, right? So we could say that then, in other words, right? Okay. So how would we finish this up then? How would we write an equation representing the relationship between AC and BC? You said it. Well, what would it be, Chuck? Well, okay, now, hold on now. AC and BC are not things. Remember, and we get kind of lazy with this sometimes, and everybody does. But we would say something like segment AC is congruent to segment BC because they're things, right? When I put that symbol over the top, it means they're geometric things that I have to draw. Okay, good. But if we write this in terms of just the length of segment AC, that's a number. And numbers are not geometric things. Numbers are just numbers, so they're equal to each other in this case, right? So what we would just write is AC equals BC, okay? That's what we're looking for. That's the relationship. And we can see that up here. Because the segments are congruent, their lengths are equal, right? And so we would just go to, where's this? Must be this one. No. That one? Yeah, it's that one. AC and BC. Okay, so all we would do here is, right, this is just in Moodle. So I'm just going to type in that equation, right? AC equals BC, or I could say BC equals AC. Any of those would work as long as it's a true statement. Okay, right? So we got it. Okay, and there's the perpendicular bisector theorem, just a reminder, right? This is just right out of the textbook. So if, in the language of our book, if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. The example they give is if CP is the perpendicular bisector, line CP is the perpendicular bisector of segment AB, then CA equals CB, right? And then we have the converse of that also, right? We also know then that if we've just got some random point, say D, if we have a point D that we know is equidistant from the endpoints of a segment, then we know something special about where D has to be located. Where would D have to be located if it's equidistant from the endpoints of the segment? Where does it have to be then?
On the perpendicular bisector.
It's got to be on the perpendicular bisector. In fact, the perpendicular bisector you can actually think of as just being the set of all of the infinite points that are equidistant from the endpoints of that segment, right? And D is just one of those, okay? What about this guy? So same deal, CD is the perpendicular bisector of AB, so we could add the same information as before, but now they want to know, write an equation representing the relationship between AC, whoops, same one. But, okay, say they asked something different. Say they asked AC, and I'm going to make something up. Say this didn't say BC. Say that said like, how about CD? So now we want to see if we can come up with a relationship between AC and CD. Okay, is that a relationship? And we don't really know that, do we? All we know about this from the perpendicular bisector theorem is just this, right? Does that somehow imply that that distance is the same as that distance? No, doesn't, does it? Right? That's kind of a tricky one. It doesn't. There's really nothing we can. What's the answer to this? NA. Yeah, there isn't a relationship we can come up with. We don't know how they're related. Right? Does that make sense? The only thing we really know about the sides is that that one and that one are congruent. We could probably determine some other stuff. How would AD be related to AB? Could we come up with a relationship there? So you fill in the blanks. AD what? AB, or is it NA? Anybody think of anything? AB is the whole segment, right? And look, we know that D is the bisector. So what do you know about the length of AD compared to the length of the whole thing? It's half. Yeah. So we could write lots of things. We could write something like AD equals 1/2 AB, or we could write 2 times AD equals AB. Any of those would be okay. Those are all true statements. They relate AD to AD, right?
Can't you be told from this picture, like what relationship is NA?
Well, like the last one, this one, right? Because we don't know the the relationship between AC and CD? We don't know, right? We don't know that AC equals, who knows, equals 1.5 times CD. We don't know, right? There's nothing up there that tells us the relationships. Yeah. But this one, we did know, right? This is one we knew for sure because point C is on the perpendicular bisector. We know that AC equals BC for sure. That has to be true. Okay, let's look at maybe one more of those. What about this guy? Same kind of thing. CD is the perpendicular bisector of AD, so we could do that. And we could do that, right? Okay, does that imply that there's some relationship between X and Y? What are X and Y if that's a perpendicular bisector? They're right angles, aren't they? Right? So what do you know about two right angles? They're equal, sure. So there is a relationship here. X equals Y, right? Does that make sense? We could write something there. And is there a relation? What if Y was like right there instead of right there? Do we know a relationship between those two? Not really. Right? It could be anything. This is 90, but that angle could be anything, right? We don't know. I mean, it has to be less than 90 because it's acute, but an infinite number of possibilities, so we don't know. Right? What if these were, let's say, X and Y? It's a little trickier, but could we show there's a relationship there? Now, we already said that we know this is a right angle, so that's a right angle, right? Those two are congruent. We're told, we know by the perpendicular bisector theorem that AC is equal to BC, so those segments are congruent. That's a lot of information about those triangles, right? If we break this up into two triangles, a left triangle and a triangle that's on the right, what could you tell me about those triangles now? With that information. We could say they're congruent. Yeah. What would the proof be? What's the relationship that would show us that those triangles are congruent? Somebody. What do you think? What's it going to be? Oh yeah, we're going to use that. But how could we show that the triangle on the left is congruent to the triangle on the right? If we pull them apart, what's it going to be? Okay, they share a side, sure. We could say that, don't they? We could say that they share this side. That's good. We could do that. Sure. And now we could say that those two triangles are congruent by what? Okay, now that's not a, but I'm saying why do we know that they're congruent? If I've got the left triangle that looks like this, yeah, all the sides are the same. So what's that relationship? What's that relationship then? We know that the green triangle is congruent to the purple triangle by what relationship? Involving like S's and A's or H's and L's and A's. Side, side, side would work, doesn't it? Right? I could say that these two are congruent by side, 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 right? And if the triangles are congruent, if we know the triangles are congruent, then that tells us a ton. Then by CPCTC, right? Which just means all the corresponding parts of those congruent triangles have to also match up and be congruent. So we could add a ton of stuff. Now we could add, well, let's see, that angle corresponds to that angle, so those are congruent. I would know that that angle corresponds to that angle, so they have to be congruent. So how are X and Y related then? What do you think, Alec? How are X and Y related? Well, it says right there, doesn't it? What's that tell me, those two marks? That they're the same. And X is it says X degrees, so X is the measure then, right, of that angle. X is how many degrees it is. So what kind of equation could I set up? X. Yeah, that's it. X equals Y, right? Okay, make sense?
You did not have to go through all of that just to say that.
Well, I mean, you don't have to write it all down, but you kind of do have to go through it because we have to somehow be able to justify, not just because it seems like they should, but we have to be able to justify why those angles are congruent, right? Because we don't know that directly, but we know it because that triangle and that triangle are congruent, and so that carries them along with it, because those are corresponding angles.
Okay.
Does that make sense? Okay, all right, so next step is just to jump in and do this. So first thing you gotta do is the E-tick, then you can do anything. Go to 205 and get going.